Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. In this question we've got euros and we've got pounds, and we're told that £1 is 2.23 euros. And we're trying to get to understand what 2,676 euros is in pounds. And we're going to do that by finding out what €1 is and then finding out how much 2,676 are. So, to get from 2.23 to 1, we divide by 2.23. And we're going to do that on both sides. And when we do that, we get 0.448 blah blah blah. And then to get from 1 to 2,676, we are times by 2,676 on both sides. And when we do that, we get £1,200. So 2,676 euros is £1,200. The first piece of information I'm going to focus on is the fact Denver gets 8/19. Denver gets 8/19. That means that Engel and Fido together must get 11/19 because they have to add up to 1. So we're only looking at 11/19. I'm going to focus on the ratio next of Engel to Fido. So it's 9 to 5. And let's have a look and see, well, first of all, how many parts there are all together. So 9 plus 5, which is 14 parts. So there are 14 parts in total, and the share that they get is 11/19. So what I'm going to do is find out what fraction one of those parts is worth by dividing 11/19 by 14. So each part is worth, and I'm just going to keep this into my calculator, 0.041 blah blah blah. And we're asked to find Fido's share. Well, Fido has 5 parts. So Fido has 5 parts, each of them worth 0.041 blah blah blah. I've kept it in my calculator to keep the accuracy. And when I do that, I get 0.206 blah blah blah. And we're asked to work it out as a percent, so I'm just going to times that by 100. So we have 20.676 blah 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 percent, and it wants it rounded to the nearest percent, so that would be 20%. Or actually, it would be 21% because this would round it up, so 21%. There's a lot going on with this question, so I'm going to start off just having a look at the total amount of money. So I'm going to do this in pence, so 2,115 pence. And if each merit point is worth 3 pence, then we can work out the amount of merit points by doing 2,115 divided by 3. So that gives us 705. So there's 705 merit points. Next, have a look at the question here, this part here, where it says James has X merit points. Sarah has 4 times as many points as James, so she's going to have 4X. Robert has 69 fewer merit points than James, so he's going to have X minus 69. And we know that that equals 705 because we've just worked that out. And this feels like a solving coming on. So we've got x plus 4x plus x, which is 6x. Minus 69 equals 705. And we're going to add 69 to both sides. So we've got 6x equals 774. Then we're going to divide 6 both sides. And so we've got x equals 129. So x equals 129. That means James has 129. Sarah has 4 times more, so she will have 516. And Robert has 69 fewer, so we're going to take 69 away from that, and that will equal 60. So in this question we are told that the centre of enlargement is at 6, 4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement, and we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here, and so that would be -4, 1. So we know that the equation of all linear graphs, which we have here, is going to follow the y equals mx plus c. And we need to find out what the m and the c are. So we're going to first of all work out what the gradient is. So that's going to be m. And the gradient is the change in y over change in x. And a different way we can write that is y2, so the y coordinate of the second coordinate, the y component in the second coordinate, take away y1, over x2, take away x1. And so y2 is going to be the y coordinate of the second component, which is there. That's going to be 40, take away y1, which is going to be 31. And then that's going to be over then the x component, so 24, take away 18, which is the x component for the first equation. So it's going to be 9 over 6, which is going to be 3 over 2, because it's just simple cancelling. So we know that m is 3 over 2, so we can actually just write out that that's going to be 3 over 2x, but we still don't know what the y-intercept is. So what we can do is have a look at the first coordinate, and for the first coordinate we've got an x and y coordinate, so we know what x and y are. So what I'm going to do is just write out the equation I've just written out, but instead of writing y, I'm going to write in 31. Instead of writing x, I'm going to substitute in the 18. So it's going to be 31 equals 3 over 2 times, and the x component was 18 for our first coordinate, and then we've got the plus c. And so all we need to do now is solve it. So there's going to be quite a few components here. We're going to do 3/2 of 18 first of all. So 3 over 2 times 18, well that's going to be 27. And then we're going to subtract 27 both sides. And when we do that, we get the fact that c equals 4. Now if we know what c equals 4, we can then substitute that into what we know. So it's 3 over 2x, and we know that c is 4, so it's going to be plus 4. Let's write that in our answer. So 3 over 2, it could be 3x over 2. You could put the x into the fraction, and then plus 4. So when we say y is directly proportional to x, what we mean is whenever x doubles, y will double. Whenever x halves, y will halve. Now we've got this proportionality sign here, and to make that an equals, all we need to do is introduce a k constant to the right hand side. So it's y equals something times x. Now to find out what that something is, to find out what that constant is, what we're going to do is feed in the value of y and the value of x that we have. So we're going to feed those in. So y is 55.3 and x is 7. So it would be 7k. And we're just going to put our lines in and solve this. So it's going to be divide by 7 both sides. And 55.3 divided by 7 is 7.9. And that's what k is. So we're going to rewrite this equation here, this formula here, y equals 7.9x, and that is actually our answer. So there's a few different ways of working out this question, but they all involve working out the area of the cross-section. And the cross-section is the part here. So we want to work out the area of this. And what we can do, and this is one of the methods, is we can work out the area of the full rectangle, which will be 28 by 19. And we'll call this A. And then we can take away the little part that is not there. So the missing part, which is going to be 14 across. We've got to do a bit of maths here to work out how high it is. So we've got 28 in total, 21 we don't want, so that would be 7 high. We're going to call this B. So work out the area of A. It's going to be 28 times 19, which is 532. Work out the area of B, which is going to be 98. And then to work out the area of the cross-section, we're going to do the big rectangle, take away the small one, take away the bit we have missing, and that will leave 434. Now the volume of any prism is area of cross-section, so cross-section area times the length. So our area of cross-section is 434. Our length is basically how 3D the shape is, so it's going to be 10. And so that would be 4,340. So our answer is 4,340 centimetres cubed. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represents plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. To be able to work out this question, we need to work out the amount of student hours required to paint the wall. And to work that out, we've got 6 students and it takes them 11 hours. So 6 times 11 means it's going to take 66 student hours. So if we had 1 student, it would take 66 hours. 2 students would be half of that because they share the work, and etc, etc. So here we've got 6 students and it take 11 hours. And it says how long will it take 7 students? Well, if there's 66 hours, or student hours, but they're sharing the time, we just divide 66 by 7. So 66 divided by 7 is 9.428, blah, blah, blah. And it says it wants its 2 decimal places, so it will take them 9.43 hours. Now check this makes sense. We've got 6 students and it takes them 11 hours. So we'd think if we had more students helping to paint the wall, it would take less hours. So we've gone from 11 hours to about 9.5. So that sounds right. So we're going to start off with 100%. And it says that the card depreciates. That means goes down by, so it goes down by 1.7% every year. So we do 100 take away 1.7, which is 98.3. And that's percent. And we want that as a decimal, or as a multiplier we call it. And so we just divide it by 100 to make it into a decimal, 0.983. And that's our multiplier. And the beautiful thing about a multiplier is we just need the amount of years. Well, it says from 1980 to 1985. So that's going to be 5 years. So it's going to be 5 years. And so what we do is we get the original amount, which was 2,245, and times it by the multiplier 5 times. Now I can't be bothered on my calculator to times it by 0.983 5 times. So what you can do is you can do it to the power of 5, which basically means the same thing. And that gives us 2060.553. And when we round that, that would be £2,060 and 55 pence. The equation of any straight line can be written as y equals mx plus c. So we need to find the gradient, which is m, and the y-intercept, which is c, for this line. Now, we are given a clue. We're told that it's parallel to this equation here, but we're not really interested in the plus 5 at the end. What we're interested in is what the gradient of this line is, which is 11, because all parallel lines have the same gradient. So we actually know what the gradient is for the line we're trying to work out. It's going to be the same because it's parallel, so it's going to be 11. So all we need to do now is find out what that plus c is. And what we're going to do is we're going to substitute in the values of x and y for the coordinate we're given on the line. So it's going to be 46 equals 11 times 4 plus c. And we just need to solve this. So first thing I'm going to do is just times the 11 and the 4 together to make 44. And then I'm just going to take away the 44 from both sides. So we get 2 equals c, or c equals 2. And we can put that into our equation. And that is our answer. So it's going to be 11x plus 2. Whenever we're asked to compare two box plots or two cumulative frequency graphs, or a cumulative frequency graph and a box plot, you're always going to be comparing two things. You're going to be comparing the median and the interquartile range. Now if we do a little table, like a good table, and we've got male and female, and we're going to work out the median, which is the first thing we have to compare, and the interquartile range. And it can actually just be the normal range. We don't need to pick the interquartile range. So the median for male is this line here, this bit here. And if you look down, that is 22. And for females, it's this one here. If you look down, that's 18. And we just go write a sentence. So you say something like the median is higher for males, brackets 22, always show your values, than for females, brackets 18. Okay, easy. Next we're going to do interquartile range. Interquartile range is slightly harder because you need to do the distance between the upper quartile, which is this line here, and the lower quartile, which is this line here. And so that would be 24 take away 19, which would be 5. And for the females, it would be 28, which is this one here, take away 16, which is this one here, and that will give you the answer of 12. So the next sentence we say is the interquartile range. They don't mind you writing IQR, that's absolutely fine. Is, now you can say lower for males or higher for females. I'm going to say lower for males, brackets 5, than for females, bracket 12. Now, the median is basically on average the males are higher, Okay, so it's just an average, says on average they're higher. The interquartile range is an interesting one. Anything to do with range is about consistency. So it's actually quite good in many instances to have a lower interquartile range because it just shows you're more consistent. So you say the sentence could be that the males are more consistent because the interquartile range is lower. Generally speaking, the higher the median, the better. The lower the interquartile range is, the better. Apart from if you're talking about things that like the time it took you for a race, you kind of want the median to be lower. Still, you want the interquartile range to be lower because you want to be consistent. So the way functions work is that they actually queue up, and the function nearest the brackets is the first one to go. So the f will be the first function we look at. So all I'm going to do is just leave the g on the outside and just put a set of brackets down. So to do f of 4, all we do is we feed in that 4 into where x is in the function f of x. So instead of 5 times x, it will be 5 times 4, which is just going to be 20. Now that's the f of x sorted, and we're now going to look at the g of x. The g of x says that it's going to be 3 plus 2 lots of whatever's fed in, and we're going to feed in that 20. So it's going to be 3 plus 2 times the number we're feeding in, which is 20. And 2 times 20 is 40, and then 3 plus 40 will be 43. So our answer will be 43. Okay, so first thing I'm going to do is just a quick sketch of this diagram. So we're told the lengths are 8 and 6, and the angle between the lengths is 64 degrees. And we've kind of got a missing length down here which we need to find. So we need to find that one. Okay, so let's label them. Now we're going to be using the cosine formula. So cosine formula involves angle A. So we're going to label the angle A. And the one opposite, the one we label as A, is going to be little a. And then little b and little c, it doesn't matter. Right? It doesn't matter which way around you do them. So we're going to write down the cosine formula. So it's a squared equals b squared plus c squared minus 2bc cos a. And so that would be x squared equals, and that will be 8 squared plus 6 squared minus 2 times 8 times 6 times cos 64. And that will be x squared equals 57.916 blah blah blah. And we just need to solve this, and we can solve it by just square rooting both sides. So it would be x equals 7.61000 blah blah blah. Okay, we're asked for the perimeter, and so we need to do 8 plus 6 plus that 7.610 blah blah blah. I've still got on my calculator, and that equals 21.610 blah blah blah. It says it wants its 2 decimal places, so it will be 21.61. So we're told that y is inversely proportional to the cube root of x. And to get rid of this proportionality sign here, we just convert it to an equals and times the right hand side by k, which represents a constant. And we now need to figure out what that constant is. So we're going to feed in the value of y and x that's given to us in the question. So we've got 10 equals k over cube root of 343. Okay, next thing we're going to do is we're going to solve that. So put our lines in. Now the cube root of 343 is 7. So we can actually just, it's a lot easier, and we're just going to times both sides by 7. So k equals 70, and we're just going to rewrite this, but instead of k, we're just going to write 70. So y equals 70 over the cube root of x. A +1 inside the brackets will mean that we're doing the opposite. So a +1 you'd think would move the graph right 1, but it doesn't. It moves the graph left 1. So we're just going to go through each of the points on the graph, and we're just going to shift the points to the left 1. And when we do that, we get something like this. And then obviously we need to join these up with one straight line, which I've already failed at doing. And there we go. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.